Hi friends, welcome to this class on units and measurement. So this is a really important class where we are going to be talking about units and measurements in physics, and it's important for all classes. So whether you're in class 7, 8, 9 or 10, this topic is really important for you. Hi, good evening everyone. I see a lot of you are out here. So welcome to this really important physics class on units and measurement, and be sure to watch the entire class, because this topic of units and conversion of units confuses everyone. We make silly mistakes in our tests, right? And I'm going to make the concepts really clear for you. So be sure to watch this entire class, and welcome to this live class of Manocha Academy. So guys, hope you're doing good and safe. And guys, if you haven't checked out our website, do check it out. It's manochaacademy.com, and we've got these courses for you: the physics CBSE class 10 course, the chemistry course, which we recently launched, this one, right? The chemistry class 10 course, and then we have the physics CBSE class 9 course here, the ICSE class 9 course. So guys, do check it out. We've got big discounts going on, so check them out, and you can watch interactive videos covering the entire syllabus. And we've added live classes right to our website as well, and there'll be quizzes and questions, and you get direct replies from me. So I'll put the links below. Guys, do check out these courses. And I'd like to start the class with a lovely quotation from the scientist Grace Hopper. One accurate measurement is worth 1,000 expert opinions. So I think this summarizes the essence of this class, because physics is all about measurement, taking accurate measurement, and science is about that, right? Science is not about opinions, it's about verifying facts with experiments and taking good measurements, right? So I hope you guys agree with this lovely quotation, and let's go ahead and begin this class. So excellent to see all of you out here, and guys, do share out our videos with your friends so that we can have more people joining this class. And if you haven't hit the like button, hit it right now. And if you haven't subscribed to our channel Manocha Academy, hit the subscribe button right now. And guys, as I said, do check out our website as well, manochaacademy.com, right? And don't forget to click the notification bell for our channel so that you get notified about the new live classes that we are having on the channel, and you get notified about the new videos. Okay guys, so thanks a lot for your support, and let's start with the class. So as you know that measurement is really important, right? And we use measurement in our everyday lives. Okay, so look at these pictures here that I've got, and let's see what are we measuring in these pictures. So let's start with our first picture here. So as you can see, a clock, right? So we measure time. For example, let's say this class is going to be 30 or 40 minutes long, right? So we can be measuring time like 40 minutes, okay? Or we could say that we have something in 2 hours, right? So we measure time with the help of a clock, and we use these measurements, right? Now, if you look at this measuring tape, right? So what do you measure with the tape? You can measure the length of your table, right? Or the length of the room. So we can have things like these measurements can be, we can measure things like 20 centimeters, right? Or we could be measuring something larger, which is, let's say, 2.5 meters, right? So we make different measurements with the tape. And very good. So what are we measuring here? Excellent, I see. We are measuring length. So let me write that here. Great, guys. And in this clock, what are we measuring? Time, right? Okay. And here you can see we've got some money here. So if we count, it's 50 plus 20 plus 10. So can you see in this picture, we've got 80 rupees here, right? So we are counting the money here. And this is, we can say we are measuring money or currency, right? So we are using these measurements all the time in our daily life. And what about this picture? Can you see we are measuring the mass or the weight of the apples here? I'm talking about this picture below, right? So let's say those 3 apples weigh something like 300 grams, right? So we say the mass of these apples is 300 gram, right? And let's say you can see this boy is standing on the weighing scale, and he's measuring his weight, okay? But in physics, you know, you are actually, when you read the value, you're measuring the mass. So let's say the weight of the person is 40 kg, right? So here we can say we are measuring mass, or informally we call it weight. Very good. I see a lot of you are saying mass. So can you see that we make these measurements all the time in our daily lives, right? Now the interesting thing is, let's take a more formal look at what are we trying to measure, right? So in physics, we call these things as physical quantities, okay, right? So you can remember the term physics and physical quantities, okay? And what are physical quantities? Quantities in terms of which laws of physics can be expressed and which can be measured directly or indirectly. So these quantities they be measured directly or indirectly, right? And the laws of physics can be expressed in that, right? So for example, we can measure length directly with the help of a tape, right? So guys, imagine we measured the length as, so let's say we measured the length as 5 meter. Okay, so that's a measurement of length. And let's say we measured the mass. Let's say some mass measurement we made, for example, 20 kg. So can you see that all this length, mass, time, right? They are physical quantities because they can be measured, right? And let's say we measured the time as, let's say 10 seconds. Okay, so these are known as physical quantities. So now I have an interesting question here. So do you think all the things, so if you look at the definition, we talked about physical quantities here, right? Which we can measure directly or indirectly, and which the laws of physics can be expressed. So do you think all the measurements here are these physical quantities? So what do you guys think? So my question is, are all of these things in the pictures here that you see, is everything a physical quantity by the definition that we had seen? Or do you think there's something here which is not a physical quantity? Okay, so what do you guys think? So which one, is there something here which is not a physical quantity? And for those of you who just joined us, this is what a physical quantity is, right? Quantity which can be measured directly or indirectly, and which laws of physics cannot be expressed, right? So what do you guys think? Okay, very good. I see some of you, Mridula, Beatbox, right? And Vijay, right? Some of you are saying that currency is not a physical quantity, right? So even though we measure currency and it looks like it has a unit, right? The unit is rupees, but we say that currency is not a physical quantity. Excellent. Money, right? So money or currency is not a physical quantity. Why? Because laws of physics don't apply on it, right? We can't apply Newton's laws of motion to currency, right? Okay, so guys, we cannot apply the laws of physics to it. So this is not a physical quantity, but all the other guys here like time, length, mass, the laws of physics apply to that. So very good, guys, those are physical quantities. Excellent. Right? So just keep this in mind. It's not that just because it has a number and a unit, it's a physical quantity. No, this was our definition. So please be clear about it. Okay, very good. And now if we say, so what is a physical quantity, right? So physical quantity we can write. So physical quantity can be expressed like this. It is basically a magnitude, right? So it's magnitude times a unit. Okay, so in a physical quantity you have a magnitude and a unit. So let me explain that to you. So for example, if we write this 5 meters, so it's basically 5 into meter, right? So the magnitude means the value. So the magnitude is 5 here, and what is the unit? Meter. Similarly, guys, if you look at this 20 kg, right? So the 20 kg, can you see? 20 is the magnitude and multiplied by kg, because it's kg is the unit. So you can think of it's 20 into 1 kg. So the magnitude times the unit. And similarly, when we measure time, and let's say the time was 10 seconds, so it's again, can you see there's a magnitude 10, the value of time, times the unit here. Okay, so please remember this really important concept that any physical quantity must have a magnitude times a unit. Okay, very important concept in physics. Physical quantity is a magnitude multiplied by a unit, as you can see in the examples here. All right, clear? Excellent. So now let's move on to this thing, right? So let me ask you this question. So you see some things in the pictures here, right? In the first picture, so let's number the pictures here. So in this first picture, you see a ant, right? In the second picture, you are seeing we're talking about the table here. So there's this table, right? The third picture, we have this boy. And fourth picture, you see the road. Now the question is, which length of unit will you use for each of these? So let's start with the first picture, right? So here we want to measure the length of this tiny ant, right? Can you see the ant in the picture? So I'm not sure if you can see that little ant over there on the leaf, right? So which unit do you think, guys, you'll use to measure the length of the ant? So what do you guys think here? So I want all of you to try. Okay, very good. So excellent. I'm seeing some answers here. I want everybody to think. So some people are saying millimeters, some are saying centimeters. So good answer. So yes, we can measure the length of the ant, right? So that can be measured in millimeters, right? Or centimeters, because ant is a tiny thing. So we use a small unit of length, right? We don't go for a large unit. Excellent, right? Because maybe the length of the ant is maybe 1 centimeter, or maybe we can say 8 millimeter, right? So we need a tiny unit. Very good. Now what do you think, guys? Think practically. If you are measuring the length of the table, what unit will you use of length for that? So here the physical quantity is length that we are measuring, right? So guys, look at the second picture where let's say we want to measure the length of the table, this length, right? So what will you use? Very good. I'm seeing some units here. So meter, very good, right? Or some people are saying centimeter. Yeah, so and somebody is saying in feet, inches, right? So there are different units, so which we use in our daily lives. So yeah, we can go for meters. You might want to make accurate, you might want in centimeters also, right? Let's say the table is 120 centimeters or 1.2 meters, right? Whatever measurement you are taking. And what is the length of the meter? You might have seen in the shops where they sell cloth, right? They have the meter scale, okay? Because cloth is sold by the meter. So you must have an idea, right? That a meter is a long unit, right? So very good. So here we use meters, which is symbolized by M. Now let's say we are interested in measuring the height of this boy, okay? So let's say this boy is, let's say 5 years old, right? And we want to measure his height. See, 5 years is again a physical quantity, right? We are measuring time, 5 years, okay? And here we are interested in the height of the boy. So what unit you'll use? Great, I'm seeing some very good answers because you know, guys, we usually practically measure it in feet and inches. So can you see the different units of length being used here? So feet or inches, right? You could also do it in centimeters or meters, right? But usually when you go to the doctor and he asks, what is your height, right? You'll say something like 4 feet, some inches, or 5 foot, 1 inch, right? So you'll measure your height based on that. Excellent, guys. And now let's say we want to measure the length of this road or the distance traveled, right? So let's say you're traveling from place A to B and you're traveling and we want to measure the length of the road, right? So the entire length you've traveled here. So what will the unit be for this? Okay, I see Urvashi says kilometers or miles. Very good. So mile is also a unit, kilometers or meters. So yes, usually for distances, we usually use kilometers and which is more common in India, and in the US they use the term mile, right? So different countries have different units and we use these according to our convenience. So can you see just this physical quantity length has so many different units, which makes this topic interesting and hard, right? Because we need to convert into different units. So you need to have an idea and practical idea of which one is useful. So depending on the size of the object, we use a convenient unit because we don't want to measure the length of the ant in kilometers, right? Or we don't want to measure the length of the road in centimeters. It will be a huge number. Okay, so very good. I see a lot of you have a good idea about this. So let's continue further our discussion on units. So as you saw, we had a variety of units here. So that's why in physics, the scientists have classified these into their different unit systems. Okay, there's the CGS system, the FPS system. So let's go one by one, right? The first system, CGS, stands for, some of you may know this, centimeter, gram and second. Okay guys, so this unit system stands for centimeter, gram, second. So what do we mean? The length is measured in centimeters, the mass, okay, so the mass is measured in grams and time is measured in seconds. Okay, so CGS is one of the old systems which was very commonly used. And then there's this British system you might have heard of, FPS, right? The foot pound, right? Where length is measured in foot, mass is measured in pounds, right? Because let's say we take 1 pound of chocolate, right? Or something like that. So that's used. And time is measured in seconds, right? And then there was the MKS system, which was meter, kilogram, second, right? So in this system, length is measured in meters, mass in kilograms and time in seconds, right? And then there's this system which is most commonly used. Guys, do you know what does SI stand for? So the SI system, which is now the most standard system in the world, okay, right? Okay, excellent. I see Shreyash has the right answer. Système d'Internationale. I don't know if I pronounced it correct. I think it's a French word. So forgive me if my spelling is wrong. So it's something like Système d'Internationale or something like that, right? You can check it in your books. Internationale, right? I think it's a French word. And so this is commonly known as SI. And this is the most widely used system, and it's basically derived from the MKS system because we have the same thing in the SI. It's measured, mass, length is measured in meters, mass is measured in kilograms, and time is measured in seconds. Okay, and guys, don't confuse this M with this. So let me write mass there, and the M here means meters. So what is important about these systems is the scientists have fixed these systems. So we can't say that, hey, I don't like length being measured in meters. SI, I'm going to write it in centimeters, okay, or maybe in kilometers. You can't do that. If you're in the SI system, the length has to be expressed in meters. Whether it's a short length or a long length, if the question says write the answer in SI unit, you have to use meter for length. Okay guys, so get this concept right. If they say find the mass, you have to write the answer in kgs if they're asking you to do it in SI units. Okay, and time has to be expressed in seconds. But if the question doesn't specify the system, then you can use the convenient unit. But usually, you know, to convert and have all your physical quantities in the same system, SI is the most common and used by most of the schools and most of the boards, right? So guys, you must be really familiar with the SI system and remember mass, meters, kilogram and seconds. And we'll talk about some more units. Now let's see, can we convert between these unit systems? Absolutely, right? So like you can go from the SI unit of mass, which is kg, to the CGS unit, which is gram. So we are talking about this point. So this question here, guys. So can you tell me 1 kg is how many grams? Excellent. Even before I ask the question, you guys have the answer. Superb. You guys are awesome. So very good. So 1 kg is 1000 grams, right? So see, you can easily convert. Okay, similarly we can write the opposite. 1 gram is 1 by 1000 of a kg, right? And this, you know, we can express it as 1000 is 10 to the power 3, so this will become 10 to the power minus 3 kg, right? If we write it in the using the exponents, the indices. Okay, similarly guys, do you know what is 1 foot in the FPS is how many meters? Does anybody know? Superb. I see number 1 app world, he has the right answer, right? Excellent. 0.3 meters. Superb. So 1 foot is 0.3 meters, right? And some of these units, if you are not familiar, you can actually Google them, right? So Google has a nice calculator where you can just write 1 foot equals how many meters and it gives you the answer. But it's really good to know these things, right? Because next time when the carpenter comes to your house, you won't have any problem because they don't always use the SI units, right? They're using like foot or something, or sometimes if you go shopping and they say pounds there, you should know how to convert. Okay, so these are very useful, not only for the exam but for your daily lives, to know these units is very important. And as I said, the most important unit out of these systems is the SI system, and CGS is also very commonly used in the questions, right? So FPS, MKS is basically, SI is now a superset of MKS, right? It has some additional units which we'll talk about. Okay. Now one important thing, since we've talked about so many different units and quantities, we can actually divide the units or quantities into fundamental and derived units. Now what does this mean? So fundamental units are units which can neither be derived from one another nor they can be further resolved into any other units. Okay, so let me explain that with a simple example. So if you take the unit of length is meter, right? We said in the SI system, it's measured in meter. Now meter cannot be broken down further into some other unit like seconds or a kilogram or something like that, right? Okay, you can't say I can convert meter to centimeter. You're still in length. Okay, so length is a fundamental quantity, right? So we are talking about fundamental units or fundamental quantities. So length, guys, is a fundamental quantity and meter is a fundamental unit, right? Similarly, time, right? So time, guys, it's a fundamental quantity and the unit, fundamental unit is seconds. It can be minutes or hours if you're not in the SI system, but second is the fundamental unit here if you're talking about that system. Okay. Now what are derived units? So units of physical quantities which can be expressed in terms of fundamental units. And I'm going to show you some examples of that, right? So fundamentals are the absolute, like the name suggests you, these are the absolute basic units. So you can't break them down further, right? Fundamental units as the name suggests. But derived can be derived from the fundamental units. Okay, good. I see some examples here. So let's talk about them. We are coming to that. So what are the fundamental units in the SI system? So like we said, length, right? The length, what is the unit? It's meter, right? So it's spelled like this, or sometimes you might see this spelling of meter, and the symbol is M. Okay, guys, what is in the SI system, what is the unit of mass? Can you guys tell me? Okay, so guys, first one, length is not kilometers. Be careful, it's meter. Okay, this is again not decided by you and me, it's decided by the scientists and now it's fixed in the world. So what is the SI unit of mass? No guys, it's not Newton. Very good, it's kilogram, right? And one important point which a lot of people forget, don't write kilogram with a capital K. So I'm going to erase that. The units are always, when you're writing the unit in the full name, you write it with a, start with a small letter, kilogram. The symbol can be a capital letter, but when you're writing the unit, it's always with starting with a small letter. And the symbol is kg. So this is in the SI units, right? Okay, in CGS, you know it's grams. Time, right? So time, again, a common confusion. Some people think it's hours, it's minutes, okay? It's not your favorite unit. It's going to be, it's defined as seconds, right? And so the unit is S. Okay, so you can just write the symbol as S. Very good. And temperature, guys, this is an interesting question. What is the fundamental unit of temperature in the unit of temperature in the SI system? And temperature is again a fundamental quantity or a fundamental unit. Okay, so what do you guys think is the answer here? Right? Very good. Okay guys, it's not degrees Celsius or Fahrenheit. No, it's Kelvin. Excellent. Okay, so a lot of you've got it right, superb. So it's going to be Kelvin and the symbol is capital K. Okay, so these are some important fundamental quantities, right? There's another one there I can add to the table, electric current. Okay. So guys, do you know what is the unit of electric current in the SI system? Okay, superb. So please remember Kelvin. Kelvin, okay, is the unit of temperature, and it's 273 plus Celsius. Okay, and what is it for electric current? Excellent. I see a lot of you have the right answer. It's ampere. See, I'm writing it again with a small a, but the unit is with the symbol is with a capital A. Okay, so these are some of there are some more fundamental units. These are the important ones in the SI system. Okay, excellent. Now let's talk about the derived units, those which are derived from the fundamental unit. Okay, so we'll discuss that with an example. Let's say here, as the question says, density is an example of a derived unit. Okay, so how do we find the unit of density? Okay, what is the way to do it? First, you write down the formula. So let's say we don't know the unit of density. Okay, good. Somebody saying area, perimeter. Yes, these are derived units, right? Okay, or let me start with the simple example. Some of you are suggesting, let's start with area. Okay, so that's another good example. So if area is the physical quantity, what is its unit? Okay, so let's take a look how to, let's say we don't know the unit. So first you write down the formula of area. You know that for different shapes there's different formulas, but let's say for a rectangle it's length into breadth. Okay, so you first write down the formula. Now you break it down in terms of the fundamental quantities. Okay, so basically the fundamental quantities here are length times length, right? So breadth is another length. Okay, and then you write down the units of the fundamental quantities. So what are the units going to be? In the SI system it's meter times meter, right? Okay, so what is the SI unit of area going to be? Meter square. So see, it's that simple, guys, to derive the unit. So what is the trick? First write down the formula and break it down in terms of the fundamental quantities. Just plug in your units and you have the answer there. Okay, superb. So now let's go to our question. Let's derive the unit of density. So what is the formula of density, guys? So to derive it, actually we need to know the formula. If you don't know the formula, then you cannot apply this technique. So very good. Area is meter square. I see a lot of you got the right answer. Excellent. So what is the formula for density, guys? So density, you know, in physics is mass by volume. Okay, and we want to derive the SI unit. Okay, so in SI unit, what is the SI unit of mass? It's not grams, it's kilograms. Okay, so don't confuse that. It's kilograms. And volume, right? So volume is going to be length into breadth into height. Okay, right? So it's L into B into H. So we'll just erase that and write down the units directly now. So it's going to be meter into meter into meter, right? The SI unit is meter. So what are we getting here, guys? Kg by meter cube, and write it like these fractions so that you're clear. Okay, and then you can write your final answer as kg by meter cube or kg meter to the power minus 3, right? But I usually like this simple form, kg slash meter cube. Okay, so guys, you got the idea of this thing. Very simple. How do you get the derived units? Write the formula first, plug in the SI unit, or if you're interested in CGS system, then you'll use the appropriate units. Just plug in the units and write it as a fraction if needed, and you'll get the answer. Okay, so these are very important concepts. So kg per meter cube or kg per cubic meter, right? Okay, so very, very important, and this is how we get the units. So let's practice another question. Can you derive the units of acceleration for me? So here are the steps. Write down the formula, break it down, and guys, go ahead and try this question. So find the units of acceleration. Okay, so I want all of you to try this. So go ahead and try this question. I want you to derive the units of acceleration. So here I'm teaching you the technique. Let's say you forgot or you're confused about the unit, how you can quickly derive it. Okay, so that's the thing. So we don't have to memorize some of the units at all. So acceleration, we know, is the rate of change of velocity. So it's basically v minus u by t, right? Okay, so, right, that's the formula for acceleration, v minus u by t or v by t. But be careful, you can't say that, so you know that what are the units here? So let's plug in the units. So velocity is again, it's displacement by time, right? So its unit is going to be meter per second, right? And that is v minus u is final velocity minus initial velocity. So meter per second minus meter per second divided by time, which is second. But guys, be careful, don't say it's going to be 0, right? Meter per second minus meter per second, because when you subtract, the unit still remains. For example, when you're doing 10 kg minus 4 kg, it's going to be 6 kg, right? So the unit still stays, right? So in the numerator, the unit is still going to be meter per second, and that's divided by time, which is seconds. Okay. And so what do we get here? So if you do the math correctly, it's going to be meter per second square. The second doesn't cancel. Be careful. So the unit of acceleration is meter per second square. Clear? So see, such a simple technique to easily derive the units, right? So it's very simple. You just apply this method and you'll easily get the units. Clear? Okay. So it's very easy, guys. Just use the formula, plug in the values. Excellent. I see a lot of you've got the right answer. Superb. Meter per second square. Okay. So just be careful about these, and you'll never go wrong in your units. So if in the test you ever have a confusion, you can quickly derive the units. Great. So here, let's summarize this thing. We were talking about fundamental and derived units. Okay. So guys, the first physical quantity, mass, right? Is it a fundamental quantity or a derived quantity? What do you guys think, and what is its unit? So let's do this table quickly together. And again, we are talking about SI units, the most popular system. So we are going to be looking in SI units. So guys, take a look at mass. Okay. So we know the unit is kg, and is it a derived unit or a fundamental unit? Excellent. Krishna, right? Shreyas, they have the right answer. Motion Planet Gaming, right? Very good. So it's a fundamental quantity. So I'm going to write fundamental here. What about length, guys? Right? So length is also fundamental quantity, right? So this is also a fundamental quantity. It can't be broken down further. And what is its unit in SI system? It's meters, not kilometers. Be careful. Mass is kg, but length is meter. Okay. Time, right? Time is again fundamental. You can't break it down further. And what is its unit? Its unit is seconds in the SI. What about volume, guys? Volume, is it fundamental or derived? Come on. Try this question. Okay. So what is going to be the unit of volume, and is it a fundamental or a derived unit? Okay. So Moksha Das Banerjee, he says derived, right? So John says derived, right? Okay, very good. Excellent. You guys are really participating here. Superb. So its volume is a derived unit, right? Why? Because volume is basically length into breadth into height, right? And so if you do meter into meter into meter, just like our area, now we'll get a meter cubed. Okay, not centimeter cubed. We are talking about SI units. So if we multiply this length 3 times, we are going to get meter cube, right? And what about density? We just discussed that. Density is derived unit, right? And it's mass by volume. So it's going to be kg by meter cube. Okay, simple, because these can be broken down further. Kg is the fundamental unit divided by meter into meter into meter, right? And what about velocity? It's displacement by time. So guys, what do you think about velocity? What is the unit, and is it fundamental or derived? So these concepts are really important, and if you get them, you'll find physics easy for you. Okay, guys. Very good. Meter per second is the unit, and as you can see, it's displacement by time. So it's length by a time, right? So definitely it is derived. So we say it's a derived physical quantity, and this is the derived unit. Excellent. You guys rock. Superb answers, I'm saying. You guys are really following it. And as you know, you might have seen this in math or physics, right? We can convert the units. So for example, if you are talking about the unit of length, okay, you've seen all these different units: millimeter, centimeter, decimeter, meter, decameter, hectometer, kilometer, right? Right? And so if you're converting, if you're going upwards, so this way, if you want to convert from kilometer to millimeters, we need to keep multiplying by 10, right? Because kilometer is the bigger unit, right? So here we can see these are the big units here, right? At the towards the bottom, and this side towards the top are the smaller units, right? So we'll take a look at this important unit conversion, but you need to know that every time, so you go from kilometer to hectometer, it's going to be 10 times. So 1 hectometer is 10 decameter, and 1 decameter is 10 meter, right? And similarly, if you go the opposite way, 1 millimeter is 1 by 10 centimeter. 1 centimeter is 1 by 10th of a decimeter. Okay, so just remember this list so that you don't have any confusion in maths or physics questions. Okay, very good. So now let's discuss some other important prefixes. So that was one list, and these are very important. So let's discuss the first one. You guys know kilo, right? Kilo, can you see here? So here so K is when kilo is said, it's the symbol is K. So for example, we say 1 kilometer or 1 kilogram, right? So 1 kilometer is how many meters? Very good. It's 1000 meters, right? So this is pretty simple. 1 kilometer is 1000 meters. So kilo basically means, so this word kilo means multiplied by 1000, or we can also write it as, if you like to remember, 10 to the power 3. Okay. So similarly, guys, you know, we can say 1 kilogram is 10 to the power 3 grams, because the prefix means what comes in the front. Kilogram, 10 to the power 3 grams. Okay. So kilowatt, 1000 watts, or 10 to the power 3 watts. Now let's talk about megawatt. What you might know is the unit of power, right? You've seen in the bulbs it's written 40 watt bulb, 50 watt bulb, but let's say you're measuring a lot of wattage, then we use this term megawatt. Okay, so guys, 1 megawatt is how many watts, do you know? Okay, yes, it's named after James Watt, the scientist James Watt. Excellent, guys. So 1 megawatt is how many watts? Some of you are saying 1000 watts. No, 1 kilowatt. So guys, don't get confused here. 1 kilowatt is 1000 watts, which is 10 to the power 3. But 1 megawatt is how many watts? Excellent. So megawatt, you can remember, is 1000 kilo. Okay. So 1 megawatt we can remember is 1 megawatt is basically 1000 kilowatts. So how many watts is that going to be? 1000 times 1000. So this is going to be 1 and 6 zeros there. 1 million, right? So we can write this as 10 to the power 6 watts. So what does this word mega mean? Mega means 10 to the power 6. Kilo was 10 to the power 3. So megawatt, 10 to the power 6 watts. Okay, please remember these important concepts. Okay. Similarly, guys, do you know what does giga mean? Right? You've seen in the computers, the CPU is 2 gigahertz, right? Right? So what does giga mean here? It is 10 to the power what? What should I write? How many hertz is that? 10 to the power? Can you guys tell me? Okay. So rather than remembering all those zeros, you can remember with the power, right? Excellent. I see Sandhya Rani says 10 to the power 9. Javed Ali says that. Superb, guys. So 10 to the power 9 hertz. So what am I teaching you in this important thing? These important prefixes, kilo, mega, giga, whether you use them with meters, watts, hertz, joules, whatever, right? Like 1 megajoule will be 10 to the power 6 joule. So whichever unit you're using it with, kilo means 1000 times, or as you can see, guys, 10 to the power 3. Then mega means 10 to the power 6, and giga means 10 to the power 9. Okay, so guys, remember this, and you can see that pattern 3, 6, 9, kilo, mega, giga. Okay, so this will really help you in the unit conversions. Now let's look at some important prefix for small measurements. These were for large measurements, because you can see it's 1000, million, and 10 to the power 9, right? So here if we look at the prefixes for small measurements, right? 1 centimeter. Okay, so how much is that? 1 centimeter is how many meter? Okay, very good. I see a lot of you are participating here. So guys, 1 centimeter is how many meter? No, I see some of you are writing 100 meters. That's wrong. Meter is larger than centimeters, you know. Centimeter on the scale, when you use a ruler or a scale, it's really small quantity. 1 centimeter is not 100 meters, guys. Be careful. I see a lot of you. So what should I fill in this blank? 1 centimeter to meter. Okay. Very good. Some of you have written the right answer. It's 1 by 100. Okay. So this is going to be 10 to the power minus 2, because why 1 by 10 to the power 2? So 10 to the power minus 2. Okay. Because we are converting the centimeter to the SI unit meter. So be careful. This is a common mistake. 1 centimeter is 100 meters. No. Think about it. Which guy is smaller? Centimeter is smaller. So it should be 1 by 100th of a meter, right? Very good. And it's not 0.001. It's 0.01. Be careful with your decimals. 0.01 meter. Okay. Clear? What about the next one, guys? 1 millimeter is how many meters? So the milli word means how much? Okay. So guys, try this. So 1 milli, very good. 1 by 1000. So you guys are getting the pattern here. This is going to be 1 by 1000, which is basically 10 to the power minus 3 meters. Excellent. Okay. So can you see these are small? So can you see there are fractions there, or 10 to the power negative exponents? Okay. Excellent. What about the next one? So this one is, let me write this. So this is called centimeter. This prefix means it's coming before meter. This is called milli, right? This one, do you know? This is called micro. Can you see that mu symbol there, right? Or if I draw it again a little larger here for you, the symbol on this line is mu, right? Okay, so micro is how much meters, right? So guys, what should I write here? 1 by 10 to the power 7? No, it's 1 by 10 to the power 6, which is basically 10 to the power minus 6 meters. Okay, guys? Okay, so remember it with this fraction or the 10 to the power notation rather than 0.000, right? You'll get confused with all those zeros. So please try to remember it in a simple way using this thing. So it's going to be 10 to the power minus 6 meters. And what about the last guy here? Nano. Okay, 1 nanometer, right? So you can guess, can you see the pattern? Milli, micro, nano. So that's going to be, okay, very good. Beatbox has that right. Jyoti Ranjan says, yeah, very good, correct answer. Even Savita Rama says the right answer. Very good, guys. Superb. 10 to the power 1 by 10 to the power 9, which means 10 to the power minus 9. And can you see why these are the negative things? Because the guy on the left is small quantity. 1 nanometer cannot be 10 to the power 9 meters, because nanometer is very small. Okay, right? It's used to measure the size of atoms or small things, right? Micrometer is used to measure the size of bacteria. Okay, so 10 to the power minus 6, 10 to the power minus 9, all these small quantities, or the wavelength of light, right? They're used for nanometer. They're small units. So you are seeing the 10 to the power minus 9. And yes, there's Fermi, there's a lot of stuff you can check in the book. I'm giving the important ones here. Do check your book for more units, right? So very good. Remember these. Now let's talk about this question. Now if I ask you, how will you convert 1 kilometer to millimeter? Okay, so guys, try this question, and I'm going to show you a very simple technique how to do this, because a lot of us make mistakes in the test when making these kind of conversions. And you know, after the test, we are like, oh God, why did I make this silly mistake, you know? So I don't want that to happen to you. So guys, how do we do this conversion? Let's see. So who can convert 1 kilometers to millimeters for me? And I'm going to show you a super easy technique to do that. Very good. I see a lot of answers here, and I think I'm seeing the correct answer. Excellent, guys. So a lot of you are saying 10 to the power 6 millimeters. Okay, I don't know. I'm going to try it out. So let's see what is the technique we're going to use here. So we've been asked to convert kilometers to millimeters, but we can't learn up so many tables, right? So we've learned all these basic prefixes where we are converting it into the main unit, right? The meter. So let's say we want to convert kilometer to millimeter. So what is the trick we are going to use? We're first going to convert kilometers to meters and then go to millimeter. So we are going to use this trick. First we'll find out in meters and then how many millimeters, okay? Because you'll see how it will simplify the things. So 1 kilometer is how many meters? So we learned kilo prefix means 10 to the power 3, 1000, right? So this is going to be 1 kilometer is 10 to the power 3 meter, simple, okay? But our goal is not meter, we are not going to stop here. We need to convert meter to millimeters, right? So this I can write as 10 to the power 3. It's basically times 1 meter, okay? So rather than meter, let me write here 1 meter, right, guys? And now what is 1 meters? How many millimeters? 10 to the power 3. So this I'll copy down. And 1 meter is how many millimeters? You know it's going to be again 10 to the power 3, 1000 times, because 1 millimeter, guys, look here. So 1 millimeter was 1 by 1000th of a meter. Can you guys see that? 1 millimeter was 1 by 1000th of a meter. 1 meter is larger. So it's going to be 1000 millimeters, right? Pretty simple. So which is 10 to the power 3 meters. Millimeters, sorry. So 1 meter is 10 to the power 3. And now what do you do? So how do we multiply these guys? So forget about the unit 10 to the power 3 times 10 to the power 3. How do we do? We just have to add the exponent. So it's going to be 3 plus 3, right? So that's the simple maths. And we are going to get 10 to the power 6 millimeters. Excellent, guys. You got the right answer. So please take a look at these simple steps I've shown you. So don't jump the steps, and you don't have to learn all the conversions. You don't have to learn 1 kilometers, how many centimeters or millimeters. Just first go to the basic unit, which you know is meters. So you need to know all the conversion with meters, and then you do that. Okay, right? Some of you are having a doubt, so just let me explain you the trick I used. I first converted kilometers to meters. So 1 kilometer, because kilo, so that's 1000 meters. And 1000 meters means 1000 times 1 meter. What is 1000 meters? 1000 times 1 meter. And 1 meter is 1000 millimeters, because 1 millimeter is 1 by 1000th of a meter. So if I write that here, 1 millimeter, you guys know, is 1 by 1000th of a meter. Therefore, 1 meter is going to be 1000 millimeters. Simple. And now if you multiply them, very easy. Okay, superb. Now why don't you guys go ahead and try this question here. 1 millimeter is how many nanometers? So you need to convert this thing. How will you do that? So try the technique that I just now told you, right? So first you convert the millimeter to our standard unit, meters, and then you go. So can you see we are doing it in a two-step process rather than trying to jump or do a quick mental calculation. We're going to do the standard unit meter and then to nanometer. Yeah, I know some of you are saying the units are pretty confusing. Absolutely. But if you learn up the table, how much each stands for, then you can do all these questions, right? As long as you know meter means what, millimeter, kilometer, the conversion, then you can easily convert these. So go ahead and try this. 1 millimeter is how many nanometers? I want all of you to try this. So what will the steps be here, guys? It's pretty simple. So we start with 1 millimeter. We're going to first convert to meters, right? And we know that 1 millimeter is 1 by 1000, right? It's smaller than a meter. It can't be 1000 meters. It's going to be 1 by 1000 of a meter. So let's write that down as 10 to the power minus 3 meter, right? You guys agree with that? So 1 millimeter, is my statement correct? Is 10 to the power minus 3 meter. But our goal is to go to nanometer. Okay, so how do we do that? So this is going to be 10 to the power minus 3 times this meter we are going to convert to nanometer. And if you look at our table here, 1 nanometer was 10 to the power minus 9 meter. So 1 meter is going to be 10 to the power 9 nanometer, right? Because guys, meter is the bigger quantity. Think like that. Meter is bigger than the small nanometer. Okay, so this is going to be, meter is going to be 10 to the power 9 nanometer. Did I get it right, guys? Do you guys agree with me here? Okay, so now you just need to do the simple exponent, the indices maths, right? So So you just need to add up these indices, 9 plus minus 3. So that's going to be 10 to the power 6 nanometer. Bingo, we've got the answer. So did you guys, I saw a lot of you guys got the correct answer. Please check if I did any simple error, right? So can you see that? So 1 millimeter is 10 to the power 6 nanometer. Let me write this last unit clearly. And this makes sense because nanometer is a very small unit. Millimeter is much larger. We measure things we see on our ruler millimeter, right? But nanometer is very small. So by common sense, it's correct that 1 millimeter is a million nanometers. It should not be 10 to the power minus 6, okay? And look at the simple steps I've shown you. Go to meter and then take the meter to the unit you want, nanometer. Okay guys, clear? Simple. And if you're having confusion, just go back and watch the video or put in any doubts in the comments. I take a look at the comments and try to reply as soon as possible. So, but guys, I would encourage you to practice this yourself. Once you practice it, don't just look at one or two sums and okay, I perfected it. Practice makes you perfect. So I want you to try this, and I'm showing you the techniques here. So my goal here is to show you the simplest techniques and the easy way how to do it, and you need to just practice it, and I'm sure you'll be able to crack these unit conversions. Now let's take a look at another very common one which is used in speed and velocity sums. 1 kilometer per hour. So a lot of people have this confusion. How do I convert it to meter per second? Okay, so guys, try this question. How do you convert 1 kilometer per hour to meter per second? And guys, thanks a lot for subscribing and liking this video. And if you haven't subscribed to our YouTube channel, hit the subscribe button right now and hit the notification bell, and do give this live class a like, and please share it out with your friends, right? So that we can have more folks on these live classes. Okay, so guys, how do we convert this 1 kilometer per hour to meter per second? So this is a more complicated question. So how do we do this? So first simple thing is you write down 1 kilometer per hour. What does that mean? 1 kilometer by 1 hour, simple. I always like to express it in simple fractions. Okay. So can you see that? 1 kilometer by 1 hour. Okay. Now some of you are saying 1000 meter per second. No, don't jump to the answer. We're going to derive it. We're going to do this unit conversion. So kilometer is, guys, how many, and our goal is what? So always look at your goal, meter per second. Okay. So we need to convert this guy into how many meter per second, right? So let's go step by step. 1 kilometer is how many meters, guys? Okay, some of you have the right answer, very good, but I'm going to show you how to derive it, right? So a lot of you are writing multiply by 5 by 18, right? Sometimes we forget that value. So I'm going to show you why the answer is going to be 5 by 18. So 1 kilometer is how many meters? 1000 meters, simple. Kilo is 1000. 1 hour, guys, 1 hour is 60 minutes, right? Times 60 seconds. So let's say this class is for 1 hour. So I've been talking for 60 minutes. So that's 60 minutes times 60 seconds, right? So this class is for 3600 seconds, but I won't multiply that because things may cancel here, right? So better not to do the multiplication, and let's see what cancels out. So these zeros are going to cancel, and we are going to be left with 10 by, so let me just write that, and again there'll be a cancellation here. So you can see we are going to get finally 5 by 18, and we converted into the unit we wanted, meter per second, right? So 1 kilometer per hour is basically 5 by 18 meter per second, and we can write it in this simple way, meter per second. And this is a very important relation to learn that will help you in the sums on motion, right? Because you can quickly convert kilometer per hour to meter per second just by doing 5 by 18. Okay. So 1 kilometer per hour is 5 by 18 times meter per second, and 1 meter per second is therefore going to be 18 by 5, right? This thing, sorry, 18 by 5 kilometers per hour, right? So do we have that right here? So 1 kilometer we converted. So that's 1000 meters, right? And the hour we converted here. So guys, take a look. Is the answer correct? So 1 kilometer per hour, very good, is 5 by 18 meter per second, and 1 meter per second, if you're converting to kilometers per hour, it's going to be 18 by 5. Okay, so you can remember this, but we can very quickly derive it in less than a minute. Excellent. So that's how we do unit conversions. Now another interesting unit conversion, can you see these are the units of density, gram per centimeter cube, right? Mass by volume. So how do you convert 1 gram per centimeter cube to kilogram per meter cube? Okay, this is very commonly used in the Archimedes questions, right? Or questions on density, relative density. So all these things help you. So guys, I want you to try this. Again, what is the technique I told you? First write down 1 gram per centimeter cube. So don't write it in this way. Write it like a proper fraction. 1 gram by 1 centimeter cube. Okay, express it clearly so that you are clear about it. And our goal is to convert this guy into kilogram divided by meter cube. Okay, so guys, can you do this for me? Please try this. So go ahead and try this, guys. Some of you may know the value, but can we derive it? It's very simple. You just need to do some conversions and some mathematics, right? So pretty simple here. So I want all of you to try this. Okay, you find it easy? Great. So go ahead and give this a shot and check your answer, right? So 1 gram is how many kilograms? So 1 gram is going to be, so if I convert the gram to kilogram, we are going to get 1 by 1000, right? Which is 10 to the power minus 3 kilogram, right? Do you guys agree? And 1 centimeter cube is how many meter cube? So this is a very common mistake. So first, rather than to avoid errors, right, we are going to write the centimeter cube as 1 centimeter into 1 centimeter into 1 centimeter, because a common mistake is just to do 1 by 100, right? But there's 3 centimeters in there, right? Centimeter times centimeter times centimeter. So what do we have here? So this is 10 to the power minus 3 kg, and each of these centimeter, you know, is 10 to the power minus 2 meter, because centimeter is smaller. It can't be 10 to the power 2. So again, our big small simple trick, right? So think about it, 1 centimeter can't be 100 meters, it's 1 by 100, 10 to the power minus 2. Okay? Right, guys? So did you get till here? Is it clear? Pretty simple. And so what are we going to get here? 10 to the power minus 3 kg by, and if we add up all these powers, minus 2, minus 2, minus 2, we're going to get 10 to the power minus 6 meter cube, right? And so now if you do this, so it's actually the 10 to the power 6 is going to go on top, the 10 to the power 3 comes here, and we have still the kg and meter cube in there. So how much are we going to get? 6 minus 3, 10 to the power 3, which is basically 1000 kg per meter cube. Okay, so take a look here, right? So the correct answer is 1 gram per centimeter cube, 1 gram per centimeter cube, right? Or let me write that in pink color since that's what I started with. 1 gram per centimeter cube is basically 1000 kg per meter cube. And this looks very confusing because we think, how can 1 gram be 1000 kg? But no, it's the unit of density. Because of those centimeters in the denominator, they went and multiplied thing. So you get the relation looks a bit confusing because you have 1 gram per centimeter cube is 1000 kg per meter cube. And a simple way to remember this is the density of water, right? So density of water is 1 gram per centimeter cube in the CGS system. So this is in CGS and this is in the SI system. It's 1000 kg per meter cube. Okay, guys. So this is what I showed you, the simple steps of how to convert. Just break it into the fractions and substitute and see, you'll get the answer pretty simply. So just be careful of the maths. And if you're not sure, practice your indices and exponents because you can see they're heavily used in the units here. Excellent. And I have this interesting homework question for you. So you need to convert 1 Newton to dyne. Okay. So you know that Newton is the SI unit of force, and remember when we write it as capital N, but when we write the unit in the full name, it's with a small n. So please remember that we don't write with capital N Newton. Okay. It's with a small n. So Newton is the SI unit of force and dyne is the CGS unit of force, and you need to find, the question asks 1 Newton is how many dyne. Okay, so remember here the question says Newton is the SI unit of force, dyne is the CGS unit, and I've also given you the formula of force. It's mass times acceleration. Okay, so you need to do this unit conversion for me as homework. and do write your answer in the comments below. I look forward to reading your comments and I promise to reply to them as soon as possible. So guys, it was really a great session where all of you were interacting and giving out answers, and I hope you found this important topic of units really helpful. Maybe I'll try to take another class on important things like least count and other important things on units as well. But this before we go into that class, you need to be very comfortable with all of these basics, okay? Because units is very important. And I remember our school physics teacher, you know, they would give us a 0 if we forgot to write the unit in the sum. So if you wrote the mass of the boy is 50, you get a 0. You need to write 50 kg, okay? So physics is all about units, and we can discuss maybe in the next class how to apply these units when solving the sums, right? So that you're converting everything into the same unit system rather than having mixed units. Okay, so guys, hope you found this session useful. So do hit the like button and do remember to try this homework question. And as I mentioned, we have this website manochacademy.com, and the best part is you can use it on your mobile, a laptop, tablet, your favorite device. It works for all devices, and we've got interactive videos. We're having live classes there as well, quizzes and questions, and you'll get replies from me. So do check out these courses, and we've got big discounts going from for you. So the links are given below, and I hope you enjoyed this really important session on units and measurement. Guys, thanks for watching. Do share it out with your friends. Hit the like button right now and hit the subscribe if you haven't. Guys, thanks a lot. I really enjoyed this session and hope you liked it as well. All right, take care. Bye.